Okay, folks, we're back with review questions. So our first review question for this week is number 8. What do the following things have in common? 32.1 grams of sulfur, 40.1 grams of calcium, and 60.1 grams of this, which I hope you can all tell me what it is. I'll write it here. Now, first, when you're naming something, you want to decide, is it ionic or covalent? Silicon is a nonmetal, oxygen is a nonmetal, and two nonmetals, of course, form a covalent compound. Covalent compounds need to use those prefixes for their name. So one silicon, we don't have to say monosilicon because it's the first of those, and we can drop the mono. If it were di, then we would have to put a prefix. So we're going to write just silicon. And we have two oxygens. Prefix would be di, ox, and then you put the IDE ending. Silicon dioxide. What do they have in common? Well, 32.1 grams of sulfur. And this is when it's important to have memorized those, chemical symbols for each element. That's why we study them. Make sure you go back and review because you'll have a quiz on all of the ones that you have previously had quizzes on, like a big monster quiz at the end. Maybe a month or two from now, right before Christmas probably. So make sure you continue to study them. They're very important for the rest of the year. So you've got 32.1 grams of sulfur. Well, if I look at the periodic table, I see that the atomic mass of sulfur is 32.1. You see that number under there, AMU. One atom of sulfur has a mass of 32.1 atomic mass units. What that also means is that 32.1 grams of sulfur is equal to 1 mole of sulfur. So I'm starting to get a suspicion here with this review question. It tells me 40.1 grams of calcium. Well, if I look at calcium, I see that the atomic mass is 40.1. That means there's 40.1 grams of calcium in 1 mole of calcium. So both sulfur and calcium have worked out to each be 1 mole. Then I look at silicon dioxide. So it says 60.1 grams of silicon dioxide. Well, is that also a mole? Let's find out. So the way you find out about this is to calculate the molar mass for this molecule. So we'll take silicon, which is on the periodic table, 28.1 AMU for 1 atom and grams for 1 mole. And then we'll add 2 oxygens. Now, one oxygen atom has an atomic mass of 16.0 AMU. So 2 of those, of course, will be 32.0 AMU. We add up, we get 60.1. So that means that 60.1 grams of silicon dioxide is 1 mole of silicon dioxide. So in this problem, the answer would be that all 3 of these represent a mole of that particular substance. So question number 9. What is Avogadro's number and what does it represent? So I hope you've memorized, and you need to, that Avogadro's number 6.02 times 10 to the 23rd. And what does it represent? Well, think about that for a minute. It represents the number of atoms of a substance in 1 mole of that substance. It's an immensely huge number, as you heard on the last video. So make sure you memorize it for the test. And number 10 of the review questions, I didn't start timing this. I'll have to cut this one short just to make sure. Number 10 says, why must a chemical reaction be balanced before it can be used in stoichiometry? Well, if we look at a balanced chemical equation, such as our favorite here, let's look at the decomposition of water. So decomposition reactions, to review, we take a compound and we decompose it into just its elements. We have to remember that these are homonuclear diatomics. Then we have to balance with the stoichiometric coefficients. So we have 1 oxygen here and 2 over there. Now we have 4 hydrogens here, so we need 4 over here, and now we have a balanced equation. What this means is not only do 2 molecules of water decompose to form 2 molecules of hydrogen gas and 1 molecule of oxygen gas, it also means that 2 moles of water would decompose to form 2 moles of hydrogen gas and 1 mole of oxygen gas. Remember, if there's not a visible stoichiometric coefficient, it really is a 1. I probably won't ever write them again to have a 1 there. You just have to know that there is a 1 there if there's not a coefficient obviously there. So why does it have to be balanced before it can be used in stoichiometry? Well, the stoichiometric coefficients there that you put to balance the equation tell how many moles or atoms of each substance will react to form exactly a balanced amount of products. And then in the practice problems in a minute, we'll show you how to use these to actually do work in the lab with maybe less than even amounts of certain chemicals. So I'm going to turn it off just because I forgot to time it. But that's the end of review questions, and then we will look at practice problems in just a moment. So I'll be right back.